Hi, in this video, we are going to give a brief introduction of what middleware is. First, we will go over some definitions of the term middleware, show you a few types of current middleware technologies, talk about how to apply middleware into IoT platforms, and also we will introduce some leading IoT middleware platforms and their products. Finally, we will show you a related project Yingnan did before. Middleware can be seen as an independent OS software or service routine located between OS and distributed applications. Nowadays, because of the quick expansion of information, a company can easily go ill for recreating its information systems. The most critical part is it needs to integrate new components or scale existing ones as efficiently as possible. Instead of recreating heterogeneous components as homogeneous ones, middleware integrates heterogeneous components as a layer that allows them to communicate despite their differences. In such a manner, middleware hides the complexity of distributed systems and allows software components running on different networked platforms to interact with one another, which makes it easier for software developers to implement communication and input-output. This slide shows the middleware architecture. First, you give orders to your computer by clicking mouse or saying a few words to microphone. Integrated circuits take this input and send them to kernel. Kernel doesn't deal with this input. It simply redirects them to middleware. Middleware takes responsibility of dealing with input. The job includes gesture recognition and speech recognition. The result is then sent back to kernel. Kernel sets up the graphic and audio display. Finally, you can see or hear the result from TV or headphone. Therefore, with middleware, we don't need to worry about details, but taking into consideration only the big picture. Here are some basic middleware types. They are remote procedure call, object request broker, and the message-oriented middleware. RPC masks remote function calls as being local. RPC is a client-server mechanism that allows the program to be distributed across multiple platforms. RPC reduces the complexity of a system that spans multiple operating systems and network protocols by hiding OS and network interface details for the programmer. ORB promotes interoperability of distributed object systems, enabling such systems to be built by piecing together objects from different vendors. While different parts communicate with each other via ORB. MOM. MOM is software or hardware infrastructure supporting the sending and the receiving of messages between distributed systems. MOM functions similarly to RPC. MOM provides asynchronous communication between client and server applications by queuing messages temporarily when one or the other is busy or not connected. Before we go deep into the trending IoT middleware, we need to first understand what IoT is. IoT stands for Internet of Things, literally the network of physical objects. Those objects include vehicles, buildings, software, sensors, washers, dryers, and so on. IoT allows objects to be sensed and controlled remotely across existing networks. Therefore, IoT creates opportunities for more direct integration of physical world into computer-based systems. It can result in improved efficiency, accuracy, and economic benefit. Then, why IoT middlewares? First, it provides safety. People can monitor and remote control any devices they own, at home or in companies. Also, it ensures organizational efficiency. IoT middleware streamlines business processes and maintains real-time information access among systems. Moreover, IoT middleware enables connecting and scaling with efficiency, analyzing and acting on new data, integrating and transforming with business processes. A few leading platforms of IoT middleware, they are Exively, Teamboon, Amazon AWS IoT, Microsoft Azure IoT. Exively is a division of LogMe Inc., offers an Internet of Things platform as a service, business services and partners that enable business to quickly connect products and operations to the Internet. Teamboon. Teamboon is a company provides a magic library called Chorale, which can let you access a lot of popular public APIs. Amazon AWS IoT is a platform that enables you to connect devices to AWS services and other devices, secure data and interactions, process and act upon device data, and enable applications to interact with devices even when they are offline. Microsoft Azure IoT provides a similar platform as AWS. As mentioned in the previous slide, Exively is an IoT-connected product management platform. Exively consists of three major components: connect, manage, and engage. Connect. Whether you are connecting an existing product, designing an IoT-enabled product from scratch, or adapting a previously IoT-enabled product, Exively has the software, hardware, and engineering experts to get you up and running securely and at scale. Manage. Manage reduce the complexity of running a connected business by building on LogMe Inc.'s heritage of connectivity and management. Engage. Exively engages with customers and transforms how products are delivered by turning data and relationship into actionable insights and new business automation. As you can see, collect is all about device setup. Manage collects and deals with product data. Engage is just a literal meaning. It engages with all related parts. Moreover, they are all built on the same API. The API supports for object modeling, authentication, time series stream, user management, chart service, ticketing, queue service, user contacts, and tagging. Data collected from manage and engage steps are also used for analysis in order to improve the efficiency of each business. This slide shows one Exively solution for Freefarm. Freefarm is a Boston-based agriculture technology company. The goal was to enable fresh food production in any environment. They faced some challenges, such as real-time data from sensors inside the farm, monitor all the key components of the farm, receive notification of any changes to the environment. Exively proposed a solution. The farmhand app now allows monitoring indoor air, temperature, humidity, CO2, and water nutrient levels from mobile phones. Graphing history and the alerts can be turned on or off, allowing the user to maintain and monitor correct temperature levels. Such solution was simple to set up, highly responsive, easy to scale, and would offer a pace to future features and services.
Okay, thanks for Yixiao's introduction. Now let me talk about the three other middleware companies and the related project I've done before. So the first company is called Timbo. Timbo is a company also considered as a middleware company, but actually has huge difference in comparison with the other three. So Timbo is actually built upon a library is called Chorus. Chorus is a library that can handle API interactions, work with databases, perform code utility functions, and more. So actually you can think of Timbo working in this way. So suppose you have a board, and the board is connected to a sensor which measuring the data from the environment, and when the data is when the sensor's data exceeds some certain threshold, the board will send a message to Timbo server center. And when the Timbo server center receives the message, it will, based on the developer's previous setting, to trigger some specific public internet event. So such as give you a phone call or send you a message. So you can the Timbo actually can help you generate the code for all these procedures. Developers do not need to worry about how to interact with the Timbo server centers. So actually, the Timbo's website can help you dynamically generate the code, and the Chorus library actually contain over 100 APIs and can interact with databases and utilities. So it's very powerful. And actually, you can programming uh, in Timbo with any kind of language on any devices. And Timbo is actually collaboration with a lot of popular development board, such as the Samsung's Arctic, Texas Instruments Launchpad, and Adreno. And you can actually develop using Java or Python or JavaScript or C Sharp to develop with Timbo's API. So it actually is a um, very powerful middleware company, but actually consider it has some different with the other three. Timbo also consider themselves as the future of programming, since the developer do not need to actually do too much coding to interact with the server center. And also, they said their coding mechanism is like the virtualized coding, since the developer can directly use abstract API from the Chorus library, and which the Chorus library has already contained hundreds of popular public internet APIs. So um, the developer can easily implement their IoT systems with Timbo. Core library is called Curious. Curious is a library that abstracts the complex exercise internet service to some simple APIs. It is a service-oriented middleware, so actually the aim of this library is to provide internet services, and it can allow developers to regulate their hardware devices. So this is also considered as a bidirectional mechanism. And Curious enable rigorous and systemized development. So actually Timbo help you generate the code for the whole procedures, and developers do not need to worry about the bugs or anything else. So it's really easy developer's life. And Curious actually already contain a lot of major internet service APIs, such as the Amazon's EC2. So you can actually use Curious to regulate your EC2 instance. You can add instance or delay instance, and open or stop it. And also the Facebook, you can use Curious to publishing something on the Facebook, and also like Instagrams, Google, or PayPal. So Curious actually is a very powerful library, and it gives developers a lot of flexibilities to let their hardware actually interact with the virtual internet services. So it's actually a pretty cool idea. This is the architecture of Timbo's cloud center. So the first is the processor receive the message from the hardware IoT devices, and then it will go to the specific service API to fetch the service and fetch the result here, and then design a runtime analysis framework, and also do some offline testing here to verify the framework, and finally deploy the executable framework result to the user level. So here is the basic step of how to use Timbo. So first you should set up your hardware. You should connect the sensor to the board and also connect to the internet. And then find out internet you want to trigger when the sensor get a certain range of data. So here we suppose we got a water pressure sensor, and when the water pressure is getting low, that means there's less water. So we want the user to receive a phone call alert. So then we can use the Timbo website to set up hardware monitor pins and generate a code based on a specific internet service event. So actually, this is automatically generated by the Timbo, and developer do not need worry any codings at this stage. And finally, add a chorus library and the code to your project and upload the code to the board, and that's all set. So this is pretty easy and pretty straightforward, and really make the embedded system developers' life more convenient. Well, here is some example of Timbo's IoT application. First is the water management, as I said in the previous slide. So you can actually implement a system that can sense the water level in a tank, and it will give user a phone call when the water levels are too low. So also you can implement some smart trash cans. You can monitor and the fill level of the city trash cans and make more efficient use of the sanitation department resource and create rich data set for city planners. Also, you can do a gas leak monitor, so you can actually detect the gas leak and build an application to monitor a gas line for leakage and allow remote control of the gas valve to prevent future further leakage. So, in my point of view, Timbo should have a very bright future since Timbo can allow people without too much coding experiences to do some small experiments at their homes, and also can allow small business companies to implement their idea more quickly and more efficiently. So I think Timbo should be more popular and more welcome in the future. Now let me talk about the Amazon Web Service IoT. So Amazon also provide web service to the IoT platform, and that can enable you to connect devices to the Amazon Web Services and other devices. So developer can use this platform to process and act upon the device data and enable applications and to interact with the device even when they're offline. So AWS IoT provides bidirectional communication between the IoT and the Amazon Web Service Cloud. So you can actually connect your sensor, your actuator, embedded devices, or other smart applications to the AWS cloud. So Amazon Web Service IoT, one amazing thing about AWS IoT is that you can actually combine others Amazon Web Services into your IoT platform. So it actually can integrate more functionalities into your IoT device. So you can actually using the Amazon machine learning or Amazon database or CloudWatch, and this actually can enhance the IoT development to the next level. So it's not the traditional IoT development. You can make them more smarter and more flexible. So this will actually help the developer implement more amazing functionalities using the IoT devices. The Amazon Web Services IoT can also be divided into several components. The first one is Message Broker. It can provide secure mechanism for IoT devices and application and to publish and receive message from each other. The second one is Root Inch. It can provide message processing and integration with other AWS services. And also the Things Registry. You can register your IoT devices and associate customer attribute with each IoT devices. And also the Things Shadow services. It can provide persistent representations of your IoT devices and the AWS cloud. And also, since Shadow, this one can be used to store and retrieve current state information of the IoT devices. And also, Devices Gateway, it can enable devices to securely and efficiently communicate with AWS IoT platform. And security services, it can provide shared responsibility for security in the AWS cloud. So now let me introduce the AWS IoT architectures. The first one is the AWS IoT Device SDK. So this is a set of client libraries to connect, authenticate, and exchange messages. This one can allow your IoT devices communicate with the AWS IoT platform using the MQTT or HTTP or WebSocket protocols. Here is the authentications. So this one can AWS IoT actually provide mutual authentication at all point of connection, so that your data is never exchanged between devices and AWS IoT without proven identity. And here is the registry. The registry actually is assign a unique identity to each IoT devices. And the device gateway, it actually can allow you IoT devices exchange messages using a publication or subscription model. This one can enable one-to-one or one-to-many communication. With this one-to-many communication patterns, AWS IoT can make it possible for connected devices to broadcast data to multiple subscribers for a given topic. And the device shadow uh, actually can provide messages, provide final messages such as the IoT device's state and the sensor's data to the client application. And the rules engine is actually can evaluate the inbound messages and publish into AWS IoT and transform and deliver them to another device or cloud services based on the business rule the developer have defined. So this is overall of the AWS IoT architecture. Alright, now let me introduce 4 small examples of IoT devices using Amazon Web Services. The first one is connect and manage devices. So suppose you have billions of devices that can publish and subscribe to the messages, and you want to manage all these messages using the Amazon Web Service IoT platform. So you can actually connect the IoT devices with the Amazon Web Services using the MQTT protocols, and messages are transmitted and received using the MQTT protocols, which minimize the code footprint on device and reduce the network bandwidth requirement. So then, as the Amazon Web Service IoT part, you can process the data and manage devices and also extract useful information from the data. And second example is a secure device connection and data. So this one is pretty like the Timbo example. So actually, suppose you get some sensor can transmit data, and you connect this securely to the Amazon Web Service IoT platform. So and then user can use their phone or use a web page to access the data and using the bidirectional regulation mechanism to feedback control the such as the fans or the water tank or such kind of stuff. So this one is a pretty traditional IoT example. The third example is called precise and act upon device data. The second one can be considered as one-to-one communication, and this one can be considered as one-to-many communication. So you can see that the sensor data from one car can be transmitted to the Amazon Web Service IoT platform and stored at S3 and also do some machine learning, data training, that kind of stuff, and then feedback the result to multiple cars so it can alert the driver that the road are slippery. The fourth example is read and set device data at any time so that the user can always using the Amazon Web Service IoT to check their IoT device's state and also to change this device's state. So this real-time monitor can make the uh, user get better control over their product. So the next middleware company I'm going to talk about is Microsoft. So Microsoft has their web cloud services called Azure, and they also have the IoT services. They actually have a similar idea with Amazon Web Services or the DAVI, but they actually powerful by the Microsoft technologies. So the key differences is that unlike the Amazon Web Services, Microsoft Azure offer a complete hybrid solution with 5 key elements: a common virtualization platform, common management, common identity, cross-platform connectivity, and a unified development environment. Together, these capabilities deliver true integration capabilities, not just a connection to the cloud. So actually, you can integrate your IoT devices with the Microsoft Cloud Services instead of Amazon Web Services. So you can actually using the machine learning services, and actually the Microsoft Azure have more services than Amazon Web Services. And you can build your product more faster with minimize the risk since you have been supported by the Microsoft experts. And also, Microsoft claimed their platform to be a complete hybrid platform. It says they have the common visualization platform so that the app can be efficiently moved between one premise physical server to another, so the developer can develop and test the app in the cloud using the same platform. And also, the developer can scale up or down to according to the business size with more flexibility. And also, they have the common management so that developer can use a standard management platform to take charge of all devices. And also, the Microsoft has a more stronger development support. You can use the Visual Studio or Eclipse to develop your system. So this is more powerful than the Amazon Web Services. Okay, here is two industry solution from the Microsoft Azure. So first one is the predictive maintenance. So actually the user want to maintain their device all over the country, so that they can use a phone or tablet to actually visualize the state of their device. So this one you can predict equipment failures before they happen and systematically prevent them even for millions of machines spread across the globe. Predictive maintenance solution take advantage of streaming data from sensor and device to recognize warning signs, predict when equipment need maintenance, and preemptively services that equipment before costly repair are needed. So there are actually 6 steps to build this whole project, such as identify the outcome and inventory the data source, capture the data, model test and integrate, or validate the model in practical and integrate into operation. So here is the visualization of the Microsoft Azure system. So you can see that we can view the state of all the equipment all over the country, and we can view the live data of the machines. The second example is the remote monitoring. The goal of this project is to monitor the fleet to gather position, status, travel info, alert. Remote monitoring solution collect live data from the assets and use the data to trigger automatic alert and operational action based on the current conditions, such as a remote diagnostic and maintenance request. So go from a manual costly procedure to one that is dynamically and automated using the IoT data. There are 6 steps to build this solution. The first one is identify the business objective and gather the resource involved, determine the component required, process the data, define the business rules, and finally operationalize and evaluate the solution. So now let's compare the price between the Amazon Web Services and Microsoft Azure. So Amazon Web Services, it is $5 per million messages, and for Microsoft Azure, it has 3 plans. You get $50 per month or $500 per month, depending on the total number of messages you want to transmit per day, and also they have the limit of the message size. So the conclusion is that the small business can choose to use Microsoft Azure since they do not have too much big data, big messages to transmit, and the big business can choose to use Amazon Web Services since it has large data size. And now let me introduce a similar project that I did before. So actually it was my last summer internship, and while doing the project, actually I didn't know that it is a middleware project, but after I studied for middleware and learned that it is a middleware project. So the project name is called Shangshui Security Information Android Application. So it is a web-based Android application that can check information from the database of the HG3000 security system. So this HG3000 actually is the middleware platform. So HG3000 is a message-oriented middleware platform which I installed at every public places such as schools, restaurants of Zhuhai, China, and other such kind of big cities. The aim is to monitor the security situation of those places, such as fire, flood, and you can check the security cameras and also provide the data to the police and the fire department. So every public places has installed front-end devices to accumulate data from the sensor installed on the building and communicate with the HG3000 servers in the data center. The HG3000 server can process the sensor data and transmit the camera live videos and store the data to the database. So actually, I developed the Android application to access the HG3000 database and visualize to users. So the major users are the police officers and the building owners. So user can be alerted when there's a fire or flood emergency in the building, and they can also search for the previous information and view the live streaming video from the building. So actually, this project can be considered as a smart security system. Now let me show the app design for the HG3000 middleware system. Sorry about that, it's in Chinese. Okay, the first one is the building is the list of the public buildings, so the police officers can check any building of the area of within their areas. They can check the sensor status and the emergency situation. So this one is the fire emergency history. So this is the time. This is the emergency status, and this one is the status for the front end device which accumulate sensor data. So for this one, this has some issue here, and this one is used for checking the live streaming videos. So the building owner can check the security camera live videos remotely. So this can enable them to monitor their homes or their buildings. So this is help the HG3000 build up a more smart security system. And yeah, thanks for watching our presentation.